Hi, welcome to an Arduino tutorial from Robojax. My name is Ahmad Shamshiri. In this video, I'm going to show you how to use 2 or more, maybe up to 10 push buttons can be used with one analog input of Arduino, so you can save the pins. With 10 push buttons, so we can press between 1 to 10 and detect it. So these push buttons can be used to control relay, load, LED, or whatever you want to control with. To control output such as relay, this time I've connected an AC bulb. You can do with something else. So when I press it, the light turns on, and when I release it, it turns off. Or you can set the output to toggle mode. When you press the push button, the light is on, and you release your finger and press it again, it will turn off. And the same way, all the 10 can be controlled with just one wire. And using it with Arduino Mega and 10 push button switches. With Arduino Due, using Arduino Nano, also with Arduino MKR. I'm also going to test the code with Potentiometer as well. You can get the code for this project by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. This is a detailed tutorial video where you will learn and customize this code for many other applications. If you don't want to learn and just grab the code and get the wiring diagram, then here is the wiring diagram. Get the code from the link below this video in the description. But if you want to learn and be able to customize this code and all your questions answered, stay tuned. A word of warning: when AC power is connected to the wall, make sure do not touch this area, and also make sure do not place the relay module on the metallic surface. Make sure it's wood, plastic, or some non-conductive material. The example that I'm providing, you can control just the output directly with relay for whatever application you have, but also I'm demonstrating and showing you to control a relay, and I'm going to connect an AC bulb here to one of them because I don't have 8 or 10. This is 8-channel relay, but we have 10 push buttons, so we will just control the 8, and the 2 others, you will understand that it will work. If you don't have 8 channels together, you can use individual of these. I have separate video explaining this relay, and I have separate video explaining this relay. So each relay has 5 volts input, ground, and signal. The signal will come from the Arduino to control it. The link for my relay videos are below the video in the description. If you have problem with these, make sure to watch those videos, please. There are instances that you need to use many push buttons, but also you run out of the digital pins that are used. So this was one of the solutions that I've seen people were asking for it, to use analog input. So I wrote this code and experimented. So we can use push buttons. So you can use these push buttons to control any of the digital pins of your Arduino board to control relay or load or LED or whatever you want to do with this. So here's the schematic. We have 5 volts, and then we have R1, R2, 3, 4, and 5. These are all 1 kilo ohm resistors connected in series. And then from 5 volts up to just above the ground, from each we have a wire that goes to a push button, and it comes here, is connected to analog 0. All of these push buttons are connected, all of them, to the same analog 0. And when the push buttons are not pressed, then we need to have a resistor to keep this input not floating but connected to the ground. I use here 1 kilo ohm, and here is 100 kilo ohm 100 times, but you can use 20 times, 50 times, it will be fine. So, but keep that in mind that you cannot have them very close. For example, you see here, this is 1 kilo ohm, and if you use 10 kilo ohm, you will not be able to read properly, because 5 of these will be 5 kilo ohm and this will be 10 kilo ohm, and you will have issue. So make sure that it is at least 20 times or higher. In this case, I used 100 times higher. So the bigger this resistor, the bigger the ratio of these two, the better the reading. And here are the main features. We need the same value of resistors for all resistors that we use. We need the same number of push buttons as the resistors. And if you're using 5 push buttons, then you need 5 resistors. If you're using 5 volts Arduino boards, you can use more push buttons as opposed to 3 volts, 3.3 volts boards, which you can use less push buttons because the voltage, when you divide it, there will be space between each value. And if you use 1% tolerance resistors, then you can use more push buttons, but you can use also 10% if you don't have 1%. And also we need a resistor from ground, from analog to ground, to avoid the floating of the input. And this resistor should be 50 to 100 times of the main resistors. The reason for that is, and this is the reason, when you have ground, none of the push buttons are pressed. This pin will be just floating if we don't have this ground resistor. So you need a ground resistor to always keep this pin ground or 0. In this case I used 100 kilo ohm. So if you use this push button, we have these 4 resistors in series. It will be 4 kilo ohm and it will be connected here. And if you use second push buttons, these 2 will left for the ground and these 3 will be at the top. And then if you use this push button, it will go like that. Push button 4 and then push button 5. When you use push button 5, you connect directly 5 volts to analog 0. The voltage of your Arduino, if you're using Arduino Nano or Micro that are using 3.3 volts, the number of push buttons will be reduced. But in those also you can use 5. But Arduino that has 5 volts voltage, you can use even up to 10 push buttons or maybe more, depending on the tolerance of the resistor. These are the carbon film resistors. So if you're using these metal film resistors, these have tolerance of 1%. When the tolerance is very high, you can use more push buttons. So keep that in mind. But generally these 10% will work for the 5 push buttons that I've just tested. And here when we press push button number 4, we have 1 kilo ohm at the lower section and 4 resistors at the top. And the equivalent of these 2 as parallel would be 990 ohm. When you have 2 resistors in parallel, if you put your ohm meter across this section to read the total value of both, then for our total we use this formula, 1 over R1 plus 1 over R2 will give us the R total if these 2 have a different value. But if they have the same value, you just divide it by 2. And the voltage that will be detected, 0.99 volts. That's 1 volt at the analog pin. And when we press push button number 2, then we have 2 resistors, 2 kilo ohm and 3 kilo ohm is left at the top. And the equivalent of these 2 is smaller than 2 kilo ohm, which is 1960 ohm. And the voltage will be 1.98 or 2 volts. When we press push button number 3, then we have 3 resistors below the push button, which is 3 kilo ohm in series, and with parallel with 100 kilo ohm would be less than 2 kilo ohm, which is 2912 ohm. And at the top we have 2 kilo ohm. The voltage is 2.96 or 3 volts if you round it. And if we press push button number 4, then we have 4 resistors below this push button and 1 kilo ohm left at the top. So this 4 kilo ohm with this 1 kilo ohm resistor would be less than 4 kilo ohm, which is 3846 ohm, and the voltage will appear to be 3.97 volts. So this is rounded to 4 volts. And when we press push button number 5, we are connecting directly the 5 volts. We do not worry about these 5 resistors, but even if you calculate it, these 2 will be parallel with 100 kilo ohm, and the 5 volts will be directly connected, and this resistor has the equivalent of 4761 ohm, which is smaller than 5 kilo ohm. Some people might ask question that how about if I use different resistor value? Yes, you can use it, but this code cannot be used for that, because in order to use the same value, the code will look very clean and easy. Now let me explain the wiring. In order to prepare these push buttons with the resistors, I've connected, let me remove these. First, to prepare your resistors, get the same value resistors, I've connected them such that from here they are connected to this, to a point where I put another resistor. So this resistor is connected to this because this line is the same. This is short circuit, all these lines. I have separate video explaining how to use breadboard. The link for the breadboard video is below the video in the description. So from this point I have connected another resistor to a point where I connected the second, the third resistor, and then the fourth, and then the fifth. From the fifth one, this is the 100 kilo ohm resistor, or the resistor that is 100 times or 50 times greater than these values. From this point it is connected to this line. This is all connected. I have spaced these wires such that from the junction between the two resistors, if you count this 1, 2, 3, I put this wire and connect it to this point, and between these two again 1, 2, 3. So this is a space for this push button. 1, 2, 3, and then between these two, from this point 1, 2, 3, and then between these two 1, 2, 3. And from here also, from the last one, we have 1, 2, 3, and it is connected. To put the push button, we will connect our push button between this wire and the junction between this resistor. And then the next one will be at the line where the wire is and at the junction. So this will be connected, and here, and here. The third one, the fourth one, and the fifth one, the last one at the top. Now for the wiring, because this is connected to analog 0, connected in here, and then this will go to analog 0 here, to analog 0. And then from 5 volts and ground, I got the red is 5 volts and the ground is blue. This is our ground, where this 100 kilo ohm is coming, and all the resistors are coming to the same point. And this last resistor and 100 kilo ohm are connected to the ground. So that is connected, and the 5 volts will be connected at the first resistor. Here, the 5 volt is connected at this point, which goes to the push button when we press it. And this is now connected to the resistor at this point. If I remove the push button, you can see it. Like that. From here up to here. The only difference in the wiring is that I put here a jumper because I connected two pieces of two breadboards here. For that, I just put this extra wire. Now it's time to hit the subscribe button so you get updates of my upcoming videos. This is an AC bulb, a tabletop. I've just bent it so you can see it. And this is the plug that is connected to the wall outlet, either 220 volts or 110 volts. And I have, from these wires, I've cut the live wire of this, and these two wires will be connected to the relay. Job of relay is to connect it and turn the light on, and disconnect it and turns it off. And each relay has 3 terminals. I will connect this to this one, normally open, and common. This is called normally closed. So even when the relay is not turned on, this will be closed. So I'm going to connect it like this in these two. So when the relay is energized, it will connect these two wires and the light will be on. These are the most famous 2 types of relay module that you can buy for Arduino. This is high level trigger relay module, and this is low level trigger. What it means is that at the input, this pin is in. Each will have 3 pins. One is for 5 volts, 1 ground, and 1 input. In order for this to turn on, we need low at the in pin, which means with the 0 volts it will turn on, and when you send anything above 2.5 or 5 volts it will turn off. But this one is the opposite. It will turn on with 2.5 and higher, and with 0 it will turn off. So this is called high level trigger, and this is called low level trigger. I'm going to connect it these 3 terminal belongs to this relay, that 3 belongs to the next one, and then this 3 for this, and so forth. And here now I've connected it to this relay. Whenever you see this will turn on, the light will turn on. And here now let me show you the wiring of 8 relay with Arduino first. On the relay we have here ground on this side, VCC on this side, where we will connect 5 volts. And then we have 8 input, N1 up to N8. So I'm going to connect ground to the ground of 5 volts and the ground of Arduino here. First I've connected this ground to the ground of Arduino, and this pin VCC, this will go to my external 5 volts. This ground will go to 5 volts, this will go to 5 volts, and then we have ground between this module and this. If you don't have a ground, this will not work. And here is 8 wires that I have. I'm going to insert it accordingly. Here I've connected 8 wires that are coming directly here to pin 2, 3, 4, 5, 6 up to 9. So now I have these 2 wires that goes to 5 volts. Now let me explain the code. At this line we define number of push buttons count, and you put the number of push buttons that you have, in this case 5 push buttons, and the resistor value that we use is 1000 ohm or 1 kilo ohm, and the resistor to ground, the resistor that we are using to be connected to ground, that's 100 kilo ohm, and that is referring to this resistor from analog pin to the ground. Then we define analog pin, in this case analog 0, and here we define our voltage for our board. In my case it's 5 volts, but if your board is 3.3 volts, you will put here 3.3, and this is now array that is holding a string value for push button name. I have defined this as push button 1, 2, 3, 4, 5, 6, 5, and these 2 extra we can delete it, but if you have more it has no harm, so I just left them there. And push button value, these are also the value for each push button, either as true or false, because it's Boolean. When we press it, they will be stored in here, so we must have the same number of count that you have, you must have it here or higher. So in this case it's 7, but we can put also 5. So as I said, more than the value has no harm, but less will give you error. And here we define output pins, pin 2, 3, 4, 5, 6. If you want to control a relay, an LED, something, whatever you have, so you can control the pins here if you want to use it. And push button delay time, this is the time when you press the push button and release it. So up to 100 milliseconds, if your hand shakes or press it twice, it will not be counted. So up to 100 milliseconds will be counted as one push. If you want to increase it, you can do so. So you can hold your hand, for example, for half a second, if you set this for 500 milliseconds, and it will be counted as one. This is the tolerance for the resistor. I'm using 10% tolerance resistance. For 10%, put 0.1, and if you're using 1%, for example, type 0.01, and for 5%, type 0.05. Debug true, this is a value. When you set it to true, it will show you a lot of values. For example, the calculated value for the voltage, the minimum, maximum, and actual voltage. So many values will be printed, which in your normal operation you don't need it. So when you don't need it, just type false. This is a bit resolution for majority of analog to digital converter of the Arduinos. It is 10 bits, but in some Arduinos, if it is 12, type here 12. Our total is a value that is. We define the output on or off. If your relay is a low level trigger and it turns on with 0, put output on to 0 and output off to 1. And if your relay is high level trigger, then for on, put here 1 and make this 0. So these two must be opposite of each other. And then this line says output toggle. If you want the output to change every time you press the push button, set this to true. So this will be one of the applications for this will be controlling the light bulb. Every time you press a push button, the light state will change from on to off or from off to on. So here, if you want the toggle to work, set it true, otherwise set it to false, F-A-L-S-E, lowercase, holding the value that is needed. This is a prototype for read push button, which is a function at the bottom of the code. Inside the setup, we define the serial monitor with 9600 baud, and if I click this, as you can see, the debug is now on. It shows here on the right side at the lower, it shows 9600. I'm going to come back to this screen, and this is just printing the text, and it prints number of push buttons, and then this text will be concatenated or be after this text. We see this, and this array goes from from 0 to 1 smaller than push button count, and defines all those pins that we have using pin mode, and picks up the pin number from the array at the top based on this I becomes 0, 1, 2, 3, and it gets the pin and sets it as output. This I, when it goes to this array, it comes here. When I is 0, it picks up 2. When I is 1, it picks up this 3, and so forth. So when with 0, it picks up this 1, 2, 3, and with 4, it picks up the 6 and brings it here. This is as if I type, for example, if it was 5, I will type 6 here as an output. So this pin will be defined using this array. It makes it, instead of 6 line, we just put this. And inside the loop, we use this function which says read push buttons. So it reads the push button value, and the values for each push button, which is either pressed or not, will be stored here. So whatever push button is pressed, one of these will be 1 or true, and false or 0 if it is not pressed. Now let me explain this before we come here. So this read push button is a function that does a lot of work here. First, we define voltage calculated, or total, voltage minimum, voltage maximum. All these variables of type float are defined, which are used next. Then we use analog read, go to the analog pin, whichever pin you define at the top of the code. Let's say analog 0. The value, which will be from 0 to 1023 in 10 bits system, will be stored here. And then we get that value and convert it to voltage by multiplying to the voltage, which is 5 volts, divided by 1023. So how we get to 1000? So how we get 1023 is that this power means 2 to the power of bit resolution. So this power of bit resolution is 10, so 2 to the power 10 will be 1024, and we subtract 1 because in our counting starts with 0, so we have 1023 different positions, steps. So 5 divided by 1023 is a fraction, multiplied by this value will give you the actual real value of voltage. In this line, if you set the debug equal true, it will print the debug information. It prints this text, the voltage, which I'm going to show you, and then it types V at the end. So these are just for debugging, and then it prints number of push buttons with this text. Here we check integer I goes smaller than number of push buttons, so this I changes 0, 1, 2, 3 up to 4 in 5 push button system. And here we calculate R total, and here how we calculate the R total of 2 resistors in parallel. For example, we have R1 and R2. If you put your ohm meter across these two, the R total or equivalent value is calculated 1 over R1 plus 1 over R2. So it will give you the R total. If these two have the same value, you just divide it by 2. So that formula have been implemented here. 1 over R1, that is R1. So we get the resistor value, which is 1000 multiplied, so we make it float, multiply by the position of the resistor. If we have 4 resistors, it will be 3 plus 1, which is 4. So 4 kilo ohm divided by 1 over 100 kilo ohm in this case. So it will calculate based on the position of each resistor, each push button. And from this, when we get the R, then we can calculate the voltage. So R times the source voltage times 5 volts divided by, this is a formula to calculate, that's the formula to calculate in 2 series resistors. It calculates the voltage. And here we check if the push button is, if I plus 1 is equal to the push button, then we know that this is the last push button. Then we know it's the last push button and there is no other resistor, so we don't worry about the calculation. Whatever is the voltage will appear at the analog pin. So we just say voltage calculated is equal the source voltage. And here we get the minimum and maximum voltage. Here, for example, in a 10% tolerance, if you want to calculate 3 volts, if this is our voltage, we go 10% high and 10% low. And when you go 10% high, it will be 3 plus 10%, 3.3 volts. And if you go to the negative side, 3 minus 0.3%, so it will be 2.7 volts. So we get 10% high and low, and because the resistors might be going up and down, so we need to find exactly. So our range will be smaller than 3.3 volts, smaller than 10% higher, and greater than 10% lower than 3 volts. So this is exactly what we do. So we get the actual calculated voltage minus, so this is 10% subtracted, and then 10%, this is the whole thing, this is 10% added. So when we add 10%, that's the maximum. When we subtract, it is minimum. So we have these variables which will be used next. And here, this is also for debugging. So this is just printing it if the debug is set to true. And if it is not last push button and debug is true, then we print all this. This is just fixing the value so it looks nice. And this is a calculated VR, minimum, maximum. I'm going to show you on the screen what it prints. Those are not important. And here we check if measured voltage is smaller than maximum, which means if it is smaller than maximum, which is 3.3 volts, and higher than 2.7 and higher than minimum, then that's our voltage. So this ampersand means this value, the result of that, and the result of this portion, if that is true. If toggle output is true, if this is true, then we get 1 minus the value that we have in the array, the status of each push button. If it is 1, for example, 1 minus 1 would be 0. So the 0 will be stored back to the state of the push button. If it is 0, then 1 minus 0 would be 1. So 1 will be stored here. And then this is a delay that we set for the push button. So in case if the person has pressed the push button for this amount of time, it will not pass, and it will keep it at that position, so it avoids multiple pressing. Else, this line, this else mean if the toggle is not set to true, then we simply put true to the state of the push button, and we have some delay. Else mean if the push button is not pressed and toggle is not set, then we just set false. Otherwise, we do not touch it if toggle is set to true. And we use a for loop to go through each value, and here we check with I, we go and check the value. If it is equal true, this means if this is equal true, this automatically it means true. It would have been excess if I had typed like this. So if that is equal true, so this was extra. This is exactly the same. If it is true, we print this text on the serial monitor with a push button number, and here for control output, we send the I, which is from 0 to 10 if we have 10 push buttons, 0 to 9, and then also we put the output on. If you want the output to be off, just use output off, the two variables that we define here at the top of the code, here on or off. Here now let me explain this one. When you pass this output on and I to this function, which is at the bottom of the code, here that on and off, which is, I call it status here with the I. It comes to this function, and whatever is the status, we use digital write and pick up the pin number, which is defined at the top of the code in here, in this array with I, when I is equal to 0, 1, 2, 3, and so forth. So that value will be picked up, and the pin number will be printed here. So we use digital write with a pin number as high or low, which is determined by output on or output off. So this will turn on and off whatever state it is, the output. The debug is on. Print this on the screen on the serial monitor to show the output is on. Otherwise, we just print off. So this is not important. It's just on the serial monitor. This line is taking the whole action here. So this can be a relay, a load, whatever you want to do with this. And if your relay needs low, change this to low to turn it on. But majority of stuff would need high, so I put high here. And these are just the text to print the corresponding pin on the screen. So let's go back here. It has 100 millisecond delay, and the loop will continuously take the same action over and over again. And here is a demonstration now. When I press a push button, the result will be displayed here. Let me press push button number 2. As you can see, it shows push button number 2 was pressed, and also it shows pin 3 is on. So whatever you have connected to pin 3 will be also controlled. Push button number 4, 5, 1. It is detecting it perfectly. And now I've turned the debug to true, so it shows everything. Let me open the screen and stop it. So you can see here, it shows 5 push button, measure voltage because I have not pressed any push button. It is 0, so resistor for push button 1 is 990 ohm for this calculation with 100 kilo ohm. The calculated voltage is 0.99 and minimum is 0.89 and maximum is 1.09. And the same way for the push button 2 resistor, it's 1960 for push button 3, push button 4, and these are the corresponding voltages. So 3.97 is, this is actually 4 volts, so 3 volts, 2 volts, 1 volt. But here the minimum maximum based on 10% is also calculated, so it will tell you the value. Now I leave this and then I push one of the buttons. So it says press push button 3. Let's see, we read 2.97, and if you press push button number 3, so we get 2.97, and our calculation shows to be 2.96. Very accurate. So if you're not using it, just make it false. Number of push buttons to 3, and I'm going to demonstrate it. And I have also 3 push buttons. Let me reset it so you can see the text. I'm pressing this reset. So 3 push buttons, and let's press push button number 3. So it says, let me hold it so you can see it. Push button number 3 is pressed. Push button number 2, so pin 3 is on. And if I press push button number 1, let me push it continuously so you can see push button number 1. And now I have set debug to true for the 3 push buttons. Let me open the serial monitor and stop it. And as you can see here, for 3 push buttons, push button number 1, the resistor is 990 ohm and the voltage should be 1.66, and here are the minimum and maximum. And push button number 2 will be 1960 ohm, and then we have 3.3 volts, and these are the minimum and maximum. Now let me demonstrate it with 10 push buttons from here up to here. The only difference in the wiring is that I put here a jumper because I connected 2 pieces of 2 breadboards here. For that, I just put this extra wire. As you can see, it says PB10 is pressed, 9, let's go, 8, 7, I'm pressing it twice, 6, 5, 4, 2, 1. So all of them perfectly. Now I have set debug equal true. Let's open the serial monitor. I'm pressing now number 6 and then stop it. Let's see, push button 6 is pressed. What was the voltage? Here we read 2.93 volts, and let's see for push button number 6, the calculate is. Now I have set this to 10%, the tolerance, and if you open the serial monitor, I'm going to show you an issue. Stop the scroll, and here all the values, the minimum for this is push button 1 and then 2 and 3. The minimum is 450 millivolts and 550, and the next one must be greater than this value for the next push button. 108, 132, that's 162, this is 176, that's good. 215, 220, 268. You see here, that's 268, this is 264. This is incorrect. So this value fits between this and this. And also 322, and this is 309. So this will create an issue in case the variation is too high. So to avoid that, we have to go with a lower percent here, the tolerance. So we have to go, let's say 0.05, which is 5%. And now let's stop it. And as you can see now, it has changed 154, 186, 205, 232. So 56, and this is greater, that's 78, that's 308, that's 326. So 413, 424, enough. So this is not overlapping now, and we can correct it using this value. And here's a demonstration using Arduino Mega. I've connected the same 10 push buttons here. Let's press number 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Just randomly. As you can see, it responds perfectly. I've connected it to 5 volts. And the test using Arduino Nano also shows it's working without any issue. And here with Arduino Due, when I press 10, still it shows 10, 10, 10, and finally this shows 8 and 9, even though the code, everything is correct, and the bit resolution is set properly, so it will not work with Due. Perhaps it needs some extra work to fix it. I tried to use it with Arduino MKR, and when I press it, it shows the wrong pin. All the values are messed up. I measure the voltage. The voltage is correct. As soon as I connect Arduino, this analog pin, the voltage is being distorted, and I could not find any documentation explaining why it is affecting the circuit. The impedance of this is affecting the circuit. So this will not work with MKR. Now let me demonstrate it with a potentiometer or variable resistor. The right pin is connected to 5 volts, the left pin is connected to ground, and the middle pin is connected to analog 0 here. And I've set it to 5 resistors. And let me now rotate this. It says push button 2 is pressed. Let me go back. Push button 1. So wherever it matches, push button 2, and then let's go a little higher. Push button 3. Push button 4. And then if I go maximum, it shows push button 5 is pressed. So different level of voltages can trigger something if you want to use it this way. Now I'm changing it to 10. Now at the middle it is around 4 or 5. So if I go here, it shows 7 now. 8 and 9, the value is in between. 9 and 10, or 10. And if I go somewhere here, 1, 4. Now we are going to test it with relay and AC bulb. I've set the output toggle to true. Now let me demonstrate it with the relay. I've connected the relay module and the AC bulb is connected to channel 1, and this is now in toggle mode. So this is the first one. So when I press it, the bulb is on. I can press it and turn it off. And I can press the second one. As you can see, the LED is on. The third one and the previous one stays there. I can turn it off. Any of these can be turned on, so up to here. And because I have 8 relays, the 2 other switch also are working. So the time that I've set is 100 milliseconds. And if you want, you can change it, make it longer or shorter. But when I press it, it responds perfectly for this application. Now I have set this output toggle to false, meaning every time I press the push button, I have to keep it pressed in order the output to reflect the state. When you remove your finger, it will go off. Now this is non-toggle mode, meaning if I press it, it's on, and when I remove my finger, it goes off. So some people need this type of application. And if you want a toggle, just go with a toggle. Thank you for watching an Arduino tutorial from Robojax. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos. In this tutorial, I'm going to show you how we can measure any DC voltage with Arduino. As you can see now, it is 12 volts, and we are reading 12 volts in serial monitor. I'm going to explain how to calculate different resistors to measure any voltage. Also demonstrate 12 volts, 24 volts, 36 volts, and 50 volts. At this point, I have a resistor, and this is called voltage of R1, and this is voltage of, and selecting R2 at 22 kilo ohm. We can measure with Arduino is 25 volts, 23.5, 23.4 milliampere. So we get 5 kilo ohm resistor. This is the formula to calculate R2 for your application.